Hello friends. So we have already discussed about the remainder theorem, the main concept of remainder theorem. In this video we are going to take up a few more complex examples and see how we can apply the concepts that we have learned so far, and we are also going to uh, provide or discuss few formulas that you can quickly apply, whereas it's totally optional because the classic remainder theorem works in all of the cases, but still there are handy formulas that you can keep in your pocket if you want to apply them, if you find a question that you can apply those formula easily. Okay, so we first discuss some of the complex situations which we can tackle using the remainder theorem. So let's take an example of a question. So let's say we have a question where we have to calculate the remainder for this. Okay, so whenever we are having a problem in this form where we have a dividend having some power, in this case we need to reach to a situation where we can get a remainder of 1, because from there the calculation becomes very easy. So I have explained it in my earlier video. If you have not given through that video, I'll give a link in the description below, so you can maybe take a look at that video first and then come back later. So in order to get our approach would be that we'll start with 83 upon 17. So what's the remainder for this number? So what's the remainder for this number? We know that 17 multiplied by 5 gives us 85. And we have 83 is 2 less than 85, so we can say that it has a remainder of -2, right? Again, I have discussed about negative remainder in my earlier video. You can go through them. Again, we have to repeat until we get a remainder of 1. So 83 square upon 17 can be written as, from the remainder theorem, it can be written as this, which gives us a remainder of 4. Similarly, this will be -2 into 4 upon 17, which is -8. 83 raised to power 4, 17 would be -2 into -8 by 17, which is 16 by 17. So again I can say it is a remainder of -1. Okay, now you can see that since I got a -1 remainder, I can reach to a remainder of 1 very easily, right? How? Because -1 into -1 will give me a remainder of 1. So that means I just have to square it. So this will be -1 into -1 by 17, which will give me a remainder of 1. So I know that uh, it is going to repeat every eighth power. It is going to be a remainder of 1, right? Because 83 raised to the power 16 by 17 will again give me a remainder of 1, because it is 83 raised to the power 8 into 83 raised to the power 8 upon 17, which is 1 into 1 upon 17. So I have to see that what is the remainder I get when I do this, right? Because that is what I'll get as the remainder. I can simply apply, I can simply calculate the remainder for that particular number, which I get as a remainder for this calculation. So this will give me a remainder of, so this 8 into 3 is 24, and then 2, then 8 into 2 is 16, so I get a remainder of 5, right? So I know that this can be, this will be, the remainder will be same as 83 for 5 into 17, right? And I just need to calculate this. Now in order to calculate 83 raised to the power 5 into 17, I have already calculated these many things. So maybe what I'll do 83 into 83 to the power 4 by 17, right? So that will give us minus 2 into minus 1 by 17, which is 2 by 17. So my remainder will be 2. I could have used any of my pre-calculated values, but anything would give me a 2, right? So I hope that you understood how we deduced to this calculation from this, right? Because when I do a division on 261 by 8, I get 3 and then 2. So 32 is my quotient and 5 is my remainder. So I can write this whole thing as 83 into 32 into 8 into 83 by 5, 83 raised to power 5 by 17, right? And I know that this remainder is 1, so I just need to calculate this one to calculate the entire thing, right? So as always, leave a comment behind if you are stuck with any of these, and if you need more clarification, I'll take that up in the next video. Okay, let's discuss another question. So let's say we have a number and we have to calculate this, right? So again, we can start with 50 by 7, which gives me a remainder of 1. And since we got a remainder of 1 in the first time, I know that any subsequent power is going to give me a remainder of 1, which means this particular number is going to give me a remainder of 1 always. Any quotient, any power of 50 when divided by 7 will give me a remainder of 1, right? So so as I was discussing about some of the formulas that you can apply, so this is one of the formula that if you can represent your dividend in a form of this, your remainder is always going to be 1, right? So in our case a is 7, so we can represent our number as 7 into 7 plus 1 by 7. So this is my a, this is my x, right? This is my a. So any number that can be expressed as this one, you directly know that my remainder is going to be 1. Similarly, if I have a case wherein I have, so I'm going to start from here, 41 raised to the power 12931 divided by 6, okay, and I have to calculate this. So as always, I'll start with 41 upon 6, which is nothing but minus 1, right? Because 7 into 6 is 42, so my negative remainder is minus 1. So and this will become 1. So I know from here I can see that any even number of this power will give me a remainder of 1. Any odd number of this power will give me a remainder of minus 1, which is 6, right? So again, it is we calculated it very simply, and again you can have a generic formula that if I have any number in this form ax minus 1 by a raised to the power n, ax minus 1 raised to the power n, and if we are dividing it by a, we can say that my remainder is a minus 1 if n is odd, and it is 1 if n is even, right? So I hope these as I told earlier that you're not expected to remember this, because the moment you start applying remainder theorem, uh, you're definitely going to get the result very soon. But if you just see that there is a number in this form, you can just tick off your answer. So I hope that the questions that we discussed today and the concepts that we discussed today were clear enough. And if you have any doubts, leave a comment behind. Do subscribe the channel so that you get notified for any of the new videos that I put for quantitative aptitude. Thank you.